Alright, part 2 of the Toyota 4Runner long crank time, lean condition. Let's do the repair. So I have a brand new Denso fuel pump. It's a small little unit. Has a little filter and some adapters here. So that's the whole kit. And like I said, you have to drop the tank on this thing. Got the shield off, and then, well, how do you unplug the sending unit before dropping the tank down? Turns out, Toyota does have a little access port to unplug the fuel pump. So my question is, why couldn't they just make the port bigger so you can change the fuel pump without dropping the tank? I don't know, but that's what we have to work with. So before disconnecting, the pump and all the lines and stuff, I want to do 2 more quick electrical checks on the original pump. I want to hook up the PICO scope and do a current ramp to see how fast this old pump is spinning and how much current is drawing exactly. We used the amp clamp last time, but a scope is more accurate. And then I want to substitute a 5 amp test light instead of the pump, just to make sure all the wiring is good, that the circuit can carry enough current. And then we'll replace the pump if all those checks are good. So let's do that real quick. Alright, here's the setup to measure the current on this fuel pump circuit. So my amp clamp is around the blue and orange wire coming off of the fuel pump relay. 1 volt is going to be 10 amps. And then the control wire for the relay, this is my control wire. If I ground this, the fuel pump should come on without running the car. So on the wiring diagram, this is our circuit opening relay. And you see the control side is fed through this ignition fuse, and then this wire, the green and yellow, that's the one I'm probed into, that is controlled by the engine computer. So we're just going to be the computer. When we ground this, the relay should close and send current through our fuel pump. Now on the scope, just 1 channel. If 1 volt is 10 amps, I just have the scale at 1 volt here, and let's just try it out. Let's turn the key on. Okay, so when I ground this, the pump should run. Let's try it. Yep, there it is, and off. That's all I want for now. Let's zoom in. We should be able to see we can see the little humps. So right now the current is about 2.2 amps. Alright. And what's the speed of the pump? On PICO it's very easy to calculate the speed. Let's bump up the scale a little bit here so we can see the humps better. And they're usually 8 segment pumps. So count out 8 segments. 1, 2, 3, 4, 5, 6, 7, 8. That'll be 1 revolution. And there's the hertz. About 3,200 RPM or 53 hertz. Okay, let's write those numbers down. I'm going to save that capture. And then we'll substitute a bright test light and see if our current goes up to 5 amps. Make sure the ground is good at the pump and the feed wire. Okay, so I have the pump unplugged, and you can see there's the blue and orange wire, and the white and black is the pump ground. So adapters, 5 amp test light, so I have 1 amp plus 4 amps. So when we hit that relay, when we click it on, our current should go up to 5 amps. So let's drop the scale again. Okay, key on. And connect that. 5 amps, bright bulbs. Nothing's wrong with the wiring. This pump is definitely weak. So now we can be 110% confident in taking the tank down all the way and replacing this pump. I asked the customer to bring it to me with less than a quarter tank, which they did, so it's nice. It's actually not too heavy. Let's pop in the new pump. Alright, here she is. Try not to break any of these crusty metal lines. So 1, 2, 3, 4 evap hoses. The fuel lines are still attached to the truck because, you know, the less stuff you disconnect, the less stuff you're going to break. Here's our prize. Sending unit, fuel pump. So let's gently remove the fuel pump from here and swap over the new one. Put everything back together. We can just lift the tank and run the pump so it picks up the gas and see what the amperage is, the RPMs, and if those check out, we can plumb in the fuel pressure gauge again. Should be good to go. Alright, here we go. Fuel tank is out of the way. Here's our sender assembly. So fairly straightforward. First, on the new pump, you want to put the filter sock on, and then it's just a hose and electrical connection. So in here we should have a little kit. That's what I'm after. It's just a little this guy right here. I love picks, and that just goes right on this nib. Okay, happy with that. Sock's not going anywhere. So we'll put this, or plug this in. Okay. Maybe plug that in later. Put it in the hose first. Just make sure the plug can reach without stretching. That's a little stretched out. Alright, let me finalize this. We'll put it back in the truck. Okay, so before we reinstall the tank, I just want to test the fuel pump on the truck and see what the current is, what the RPMs are. So adapters are, you know, make sure you have positive and negative in the right order, because otherwise the pump will run backwards and your readings will be very confusing. So the right pin is the yellow is the positive, left pin is black negative. So this is our old capture. We were at 2.2 amps. Let's roll the scope. Now let's turn the key on and get our control wire and run the pump. There we go. So it primed the system, and check out our current now. So before we were at 2.2, now we're about 4.5 to 5 amps as we're supposed to be. And let's see the RPMs now. So before we were at 3200 RPM, 1, 2, 3, 4, 5, 6, 7, 8. 6600 RPM. There we go. Exactly, it's spinning twice as fast, drawing twice as much current. Absolutely confirmed repair. We don't even need to plug in the fuel pressure gauge. We will have to disconnect the battery to clear the fuel trims. Take this thing on a rip. It should drive amazing. Moment of truth. She's all back together. I had the battery disconnected for a while to clear all the fuel trim memory, all that adaptives. So let's tighten up the terminal. Fire up the Varus, look at some live data. I'm not even going to measure fuel pressure. I know it's fixed. So we just want to make sure the fuel trims are close to zero. Take it on a test drive. and return it back to the customer. Should be driving really nicely. Alright, cold start. In the Toyota data list, you can see long and short-term trim are zeroed out, so that's good. That's what we want. Let's fire it up. And then drive it around. Look at these long and short-term trims, and they will come on when this thing reaches closed loop. And then at a hot idle, do you guys remember what the mass airflow and injector pulse width was? I think it was 4 grams per second and 3.7 milliseconds on the injector. Now what do we expect? I don't expect the mass airflow to change, but I expect this injector pulse width to drop, because now we have more, appropriate fuel pressure, and the computer won't have to fatten up that pulse width as much to keep this car happy. So let's go on a little test drive. So we're warming up. Thing of beauty. Look at that. Long term 0, short term's like 1 or 2%. Fantastic. Now that's throttle response. It didn't used to do that. Let's take it for a spin. Alright, we're doing great here. Let's see how it accelerates. Yeah, it's fine. See, cruising under load. Fuel trim right around 0. It's perfect. Great torque. So once it's fully warmed up, we'll take a look at that mass airflow reading and the injector pulse width. Alright, so here we go. Hot idle, about 4 grams per second, so that didn't change much. Look at our injector pulse width, 2.9 milliseconds. It used to be 3.7. Fuel trims are spot on the money. A couple percent there, maybe 4 or 5%. Excellent. Question is, did we fix the customer's original complaint? Long crank after a hot soak. Let's go back to the shop, park it for 15-20 minutes, fire it up. It should be good. So we're going to let this thing hot soak. It's about 240 right now. At 3 o'clock, we'll try to start it. It should fire right up. Alright, 20-minute hot soak. The idle's a bit low. I mean, is that the way it is? Definitely didn't stumble or anything. About 700 RPM. Yeah, that's where it's happy. Okay. That's it. We're done. So what's the moral of the story in this truck? You gotta consider all your data. On these older vehicles, sometimes the trouble codes, there were no trouble codes. The only customer complaint was rough start, after a little hot soak. But it had an extreme lean condition. So on this one, different than that Toyota Camry with a leaky injector. So the weak fuel pump explained all the symptoms. Now the truck is happy, and the customer can pick it up and enjoy it. So thanks a lot for watching, and we'll see you in the next one. Bye-bye.